Today, inshallah, we are going to discuss last class about correlation and regressions. In real life, we have like two variables always related together, like attending classes, get good mark. As much you study, as good grade you get. As much you eat, as much weight you gain, like this. So today, inshallah, we are going to discuss this relation. First, check about relation exist or not by using correlation. This first part about correlation, going to discuss about does relation exist between two variables. This variable should be quantitative variable, continuous, or might be discrete. If this relation exists, we will move to describe this relation by using regression. So if relation exists, we need to describe this relation. Actually, we will discuss only relation between two variables, and we will describe this relation of two variables with simple regressions, which is called like linear function. Okay, linear line function. So let's start by ending of this class. Student should know draw a scatter plot for a set of order pairs, compute correlation coefficient, compute the equation of regression line. So first, we researcher suspect there exists a relation between two variables. First step, he go to draw a scatter plot. Draw a scatter plot in order to check this relation have a special pattern or not. If this relation like positive, negative, exists relation, scatter plot gives some indication about this relation, then he moves to compute the exact value of these relations. After computing this relation, then we move to construct a regression line for these two variables. Let's see an example. Here we have example about students' score in exam and number of hours that student study per day. So we have two variables, X and Y. X is student studying hours, and score is Y. So we have 6 students, S1, S2 to S6. First student studies 6 hours at home every day. He get 86. Student 2 study 2 hours, get 61. Student 3 study 1 hour, he get 52. Student 4 study 7, and so on. Student 6 study 4 hours, get 70. Our question is, does a relation between student study hour per day and student score exist or not? We go to do first step, draw scatter plot. So x-axis, this x, this y, like bears. 6 with 86. I go to 6 with 86. This 6 with 86. 2 with 61. 2, 61. 1 with 52. 1, 52. Till last one is 4 with 70. So this scatter, we call this scatter plot. Scatter plot gives us some indication about existing of relation. Does relation exist? Yes, it look like this relation look like positive. So we indicate from this.
دكتور
Yes.
لو توني مواصل كنت في المستشفى أنا فأرفع عذر ولا وش كيف أنا؟
Yes.
Okay.
Okay, so scatter plot is the first step when researcher suspect existence of relation between two variables. After this scatter plot give us some indication about, actually it will be not like 6 students, like a lot. So for if we have like 100 students, this scatter will be more clear than this. It's just like this, like example. So for this, just we have 6 students, so it look like somehow relation exists, and it look like positive. As x increase studying time, y increase, your score increase. So as much time you study, as good grade or good score you get. So after we construct a scatter plot and we get some indication, we move to determine the exact value of this correlation or this relation. If we got like not like this, for example, if we got relation like this, here no specific button about this, so it is look like no relation, no relation, no direction for this relation. But if we find relation like this, for example, if we find relation like this, so it look like relation exists, and it look like decrease in relation. We call it negative relation. It look like positive relation. So scatter plot give us some indication about relation. So if we find it's positive or negative, we move to compute the exact value of this relation. How? By using correlation coefficient. So we move to compute correlation coefficient. Correlation coefficient is a numeric measure to determine the strengths of linear relation. Determine strengths of linear relationship and direction. Also we correlation coefficient determines the strength and relation of linear relation. Actually, we only study linear relation. We don't study non-linear or other relations. So for correlation coefficient, if we compute it for a sample, we denote it by R, which is statistics. If we compute it for population, we denote it by rho, and it will be parameters. So how to compute correlation coefficient? Let's see the equation of correlation coefficient. This is the equation of correlation coefficient. Is it clear? Correlation coefficient R equal n summation xy minus summation x multiplied by summation y over square root n summation xi square of x's minus summation x all square multiplied by this same, but instead of using x, we use y square n summation y square minus summation y I all squares. Before I go to compute this, let's see the properties of R. R should be between -1 and 1. If R more close to 1, then it is a strong positive relation. If R is too much close to -1, then R is negative strong relation. If, for example, we got R equal 0.96, for example, 0.96 is close to 1, so it is a strong positive relation. If we got R equal minus point, say 0.90. So it is negative, strong relation. Let's see more properties about probabilities of correlation coefficient. Correlation coefficient should be between minus or plus 1. Maximum is 1, or minimum is minus 1. If R close to 1, then we indicate a strong positive relationship between X and Y. If R close to minus 1, then it is a negative linear relationship. If R equals 0, this indicates no relation actually, but if R close to 0, then this indicates weak relation between these two variables. 0, no relation between these two variables. Let's see example to describe this relation. For example, if R equal minus 1, this means perfect negative linear relation. Actually, in real life, R cannot be equal minus 1. Always between plus or minus 1. In real life, because this like linear line, in statistics, we don't have this relation, this exact relation. So we don't have minus 1, we don't have 1. But if theoretical, yes, we have, and we called it perfect negative linear, of course, linear relationship. If positive, then it is perfect positive linear relationship. If it is between 0.7 to 0.9, then it is a strong positive relationship. In other side, if it is negative 0.7 to 0.99, then it is a strong negative linear relationship. Between 50 to 69, it is moderate or average positive linear relation. If it is negative minus 0.5 to minus 0.69, so it is moderate negative linear relation. Between minus 0.1 to minus 0.9, it is weak negative linear relation. Of course, 0 is no relation. If 0.01 to 0.95, it is weak positive linear relation. We can describe this by this chart. 0 is no relation. If we move in this side, it should be positive. 0.2, it is weak, weak, weak. From 0.6, maybe it started like moderate. 0.8, 0.9 is strong linear relation. This side is negative relation. If we move more close to minus 1, become more strong. If we move this side, become weak and negative. Same here is we move this side, it's gonna be strong positive. If close to 0, then it is positive weak relationship, linear relation between these two variables. Let's see this. This negative. As x increase, y decrease. So it is a negative linear correlation. This positive, x increase, y also increase, this positive. This actually non-linear, it looks like curve relation, so it is non-linear correlations. This is no relation, it looks like random relation, so there's no correlation. Maybe r equals 0 or around. So these shapes of scatter plot. Scatter plot can give us indication about direction and strength of the relations.
Doctor,
Yes.
the third one I didn't understand it.
Understand what? Which one?
The third one, that correlation.
This no correlation because this is not a specific button. It look like random X increase, Y yes king, but no like X increase, Y increase, X decrease, Y decrease. It look like random. No,
Mm.
it look between X and Y. So we call this no correlation, no relations. No relation. Why no relation? Because this no specific button. ما في نمط معين هنا.
Mhm.
Clear?
Clear.
هنا clear it is decreasing. X increase, Y decrease. Hina X increase, Y also increase. So it is positive linear relation. And this negative. This non-linear. Actually, this curve linear relation. Let's see other example. Let's see this. This might be more clear. This perfect relation. One. It's like a linear line. We don't have this in math maybe, but in statistic, no. Statistic like this. So it is R.8, it's strong or positive relations. This look weak relation, weak, it's 0.3. Is no relation, it's R, it's 0. Here is also weak relation and negative, it's minus 0.3. Here is strong and negative relation, so it is minus 0.8. This is perfect negative relation. Actually, this is a linear line. Clear? So let's take,
Clear.
yes, okay, let's take this example. We have plot 1, plot 2, plot 3, plot 4. This is scatter plot. So a match below as far as scatter plot must match each plot with its correlation. This correlation is supposed to be, we have 0.99, 0.7, 0.9, and 0.5. So which is this supposed to be? Is what? Yes, yes, yeah, Imad. Yeah,
D.
this is D. Yes.
Yeah.
This look like positive and somehow weak. This, yeah, Hussein.
B minus points minus 7.
Yes, it look like negative.
Negative, slightly moderate correlation.
So it is, yes. So this, 3. Is it positive or the negative, Abdulaziz? Yes.
It is positive, doctor. I think it is 0.9.
Yes. Last one, it look like strong, negative relation. So it is minus 0.99. This minus 0.99. Clear? So let's move to, we know how to compute R. Actually, this is a formula will be given in exam. No need to, just you have to know how to use it. But we will give it to you. Available in exam papers. Let's see this example. Our example student studying hours per day with student score. So we give you only these two columns, this X and this Y, and then we ask you to compute R. How to compute R? We use this formula. We have summation X, yes, summation Y. This is for the first column, X column. We find summation of X column, summation of Y column. Then is X multiplied by Y. So multiply each X with associates Y, X1 with Y1, X2 with X2 with Y2, till Xn, we have N equals 6. So X6 with Y6, we find summation of this. Then we move here, N is 6. summation xi square, we have to find square of each value of x, then find summation of this value to find summation of xi square. For this summation xi all square. This value same, just we do squaring. So we take this, we square it. Here also we do same. Here we have to find value of each value of y square and then find summation of these squares. For this, it's same like this. Just we find summation of yi, then we do squaring for summation yi. Let's see the example here. First, we have to find multiply each value of x with each value of y, x1 with y1, 6 multiplied by 86, x2 with y2, 2 multiplied by 61, 1 multiplied by 52, we get this. This is x by y. Then the third one, we square each value of x. X is 6 square is 36, 2 square is 4, 1 square is 1, 7 square is 49, 3 square is 9, 4 square is 16. We do same with y values. So we square 86 square equal this, 61 square equal till 70 square equal. If you find all this, then we come to find summation of this column, summation of x, 23 is summation of x. We find summation of y, then we find summation of x multiplied by y, then summation of x square, summation of y square. Now we got all summations and we know n equal number of columns, how many columns we have, number of rows, how many rows we have, 1, 2, 3, 4, 5, 6. Actually, we have 6 students, so sample size is equal 6. This is a small example. So we go to use our formula to find the value of correlation coefficient. So we got this summation x. N is 6, so we write 6. Summation x multiplied by y is this. So summation x by y minus summation x, 23. Summation y is 423. So we finish this. We go down to square root of what? Square root of n. N is 6 still. Summation xi square, this. So minus summation x all square. Summation x all square is same like this, same value. Make sure this value is this value. Here also same, make sure this value is this value. Just we do squaring. Here just we do squaring. Then R is equal by 99. So comment or in describe the relation. Just we write this relation is positive. Why positive? Because it is positive. Why strong? Because it's close to 1. Of course, linear relation, because actually this we use it for measuring linear relation between two variables. So it is positive, strong linear relation between student studying time in hour and student score. This means what? This means at as much time student study, as good grade student will get. Clear?
Clear.
Now, after we get strong positive or negative or even moderate relationship, we need to describe this relation. But if we find this relation weak, we stop here. We don't go to describe this relation. No need to describe weak relation. But now we have a strong relation. We need to describe this relation. How to describe this relation? Just to write y equal a plus b x we write it like this. Y, we know Y is dependent variable. A plus bx. We describe relation between x and y, but we have to know which is dependent, which is independent. For scatter plot is okay, no problem. If you confuse with which is x and which is y, just we can draw x instead of y, y instead of x is okay, no problem. And actually, if here, even here, if you use x instead of y, is still same, because x by y it is same like y by x. Summation x multiply summation y, it is same like summation y, summation x. Here this and this is same, and this is multiplication. So if you put this first or this second, it is same, no problem. But for computing this relation or describing this relation, we should know which is a, which is y, and which is x. Clear? So we have to know which is dependent variable, which is independent variable. For our example, it's clear. Studying hour is independent, but student score depend on student studying hour per day at home. Now, the question is how to find this. We call this intercept, and how to find this. We call this slope. If we find this, for example, let's see if we find y equal 52, or say 50 plus 1.5 x. For example, this means what? This means relation between student score and student studying hour can be described by this equation. Y equal 50 plus 1.5 x. We call this intercept. We call this slope. And always sign of slope same like sign of r. If r positive, this should be positive. If r negative, this should be negative. So sign of slope give us direction of relation. If this positive, I know this direction is positive. If this negative, I know this direction is negative, but I cannot know the strengths of relation. I don't know it is moderate, it is strong or not, but I know it is positive. Why positive? Because slope is positive. So this means what? This means if a student study 1 hour, he will get 51 by 5. Sorry, 51.5. Just instead of x, we put 1. If a student study 1, then 1.5 multiply 1 is 1.5. 1.5 plus 50 is 51.5. So if a student study 1 hour, he will get 51.5. We call this estimation. Estimation means I just use this equation to predict or to estimate upcoming or new unseen value of x. I can construct this for my student now and use it for my student of next year to estimate their score in exam. If a student study 1 hour, I just ask him, you study 1 hour, okay, you will get 51.5. Maybe he will get 52, or maybe he'll get 50, but it should be around my estimation. It will be around 51.5. So intercept is what? Intercept is value of y when x equals 0. If a student is studying nothing, just come to classes, he will get 50. This means of intercept. Clear? Question, how to compute A, how to compute B. Let's see how to compute it. Yes, for computing B, we use this, also available in exam. Just you need to know how to use. Actually, this is too much related with R. That's why they have same sign. This actually same in R. This is same. N is same. For this, just square roots of same this multiply by square root of, instead of this x, we use y. Let's see. Let's see. Let's see R and to compare R with B. B is the slope. See, this is same. This is B, by the way. This is B. We don't have this. This is not included in the slope. And no square roots is not included. That's why if this positive, B will be positive, and R also will be positive. If this negative, both will be negative. Actually, this is always positive. The square root of square, this is positive, but this could be positive, could be negative. So if this positive in R, of course, will be positive in B. So in exam, try to find this value first, put it here, then find each of this value together, because we will use this and this to find B. We will ask you first question, find R. Second question, describe the relation. Third question, find slope. So just take these values and use it to find slope to save time in exam. Let's go back to find how to compute slope, how to compute slope. Here we have mentioned slope have same sign with correlation coefficient. The slope means the average change in y per unit change in x. For example, if we say y equal 50 plus 1.5x, this means y change with 1.5. If we change x 1 unit, as we see, y change from 50 to 51.5 and so on. So why we construct this? We construct this line in order to use this for prediction. So we use this after we describe this relation. We use this to predict unseen value of x. Let's see how to compute. Already we have these values. We computed before. Now we use same summation x23, summation y is same to find b. So it is same. This value it is same. Even this value is same. But this is the first part of R. So we compute this x, n is n6, summation xi squared, this minus summation x all square. Also make sure this is this same, just we do squaring, so it is 6.2. This is slope. If we compute slope, then we have shortcut for computing intercept equal y bar minus b x bar. But if this not right in exam, also this will be not right, because this depend on this. We compute b and then we use this b to compute a. So a equal what? Y bar. Y bar is what? Actually we have summation of x, just we divided it over 6 to get x bar. I know x bar is summation, for example, x bar is summation x over n. Already I have summation x equal 23 and n equal 6, so it's 23 over 6. 23 over 6 is just 23 over 6 by calculator. For y bar, also we same. Already we have summation y, just we divide summation y over n. Summation y is 4 123/6. Now we have y bar, we have x bar. Also, already we got b, so we use y bar minus b x bar to get intercept, which is 46.7. Now, estimate the regression equation. Just we write y dash, y hat. Why we use hat or dash? Because it is estimation is not exactly. So a plus bx, a already 46.7, b is 6.2. So this is our estimated regression line. Why we estimate this? In order to use this for predict value of x. So if x equal 10, just we use, instead of x, we put substituted by 10 to find this. But actually, we don't go too far out of our values. If I use maximum student 7 hour, minimum student 1 hour, so we don't use to go too far. Just you can use 8, 9, but I think even 10 is too much. That's why we got 180. 180 exam, maybe. If exam 110 is okay, but if exam is 100, then we call this problem later. Maybe we'll discuss in your college. We call this extrapolation problem. Just we have to know we don't go too far out of our range. If we use like 7, 8, okay, don't go too far. Just use 8, 9 is okay. And now we finish class. Just we move. It is clear? Clear? Everything clear about this class? Because
Yes.
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 important, we have 5 mark in exam.
This topic
Yes,
in the final.
yes. So is
Question will be on this topic.
what?
How many questions will be taken from this topic?
I don't know, but it weight 5 mark. 5 mark, too much, by the way, in exam. Exam out of 40. 5 from this class, 5 from binomial distribution, 5 from normal distribution. So 15 out of the last 3 lectures. 15 around, but we will give you blueprint. But this is class exactly, and by normal class, we don't have quiz, no test. So this definitely will have high weight in final exam. We'll give you a blueprint in details, inshallah, next week. But put in your mind, this class is too much important. It used to be in essay questions, but it's clear, I think. Question like this is construct a scatter plot. First question. Second question, find R. Third question, describe the relation. Just you write weak, strong, positive, negative, linear relation. 3, find A. This A. Find B. Yes. Then they ask about find regression equation. This. Then they ask predict the value of if x equal 2, 3, 4, just like this. And we already give you this. This is given in exam. Just you need to practice how to use. Also this is given. R also given. Just practice, practice, practice how to use. I think it is easy, right? Let's move to worksheet. Okay.
Okay.
We need to have break or no need?
It's better
That's
to
fine.
take a break.
Okay, so let's have break of 10 minutes and come back. 10 minutes. So now let's see the worksheets. If the relation between y and x given by the equation, this is regression line equation, y dash equal 1.57 plus 0.0407x. Which of the following is true? For every unit increase in x, y increase by 1.57. Let's see. If we increase x with 1, then y will increase with, okay, if x equal 0, y equal 1.57, right? Hello?
Right. Yes.
Let's take this as initial value. Initial value of y is 1.57. If we increase x with 1, then y will increase with
Yes.
what? With this, right?
Minus, yeah.
Yes. So for every unit increase in x, if we change x to be 1, if we put 1, then y increase with this, right? Actually, this is slope division. Slope, definition of slope is the value that that y increase if x increase with 1 unit. Clear? Correlation coefficient and slope of regression line will always have what? If r negative, then slope will be also negative, right? So slope and correlation coefficient always have same sign. So by value of v, we can know the direction of correlation, but we cannot know the strength of relation. In order to know strength of relation, we have to know the value of r. But by v, we can know the direction of relations. Now let's move to 3. What is the chart called when spare data, dependent and independent variable, are plotted? So is it histogram? No. Is it time series? No, definitely. Is it ogive? No, it is scatter plot. Scatter plot, we just x and y, and then we plot paired value of x with value of y in order to see the relation between two variables x and y. As we mentioned, if we write value of y in x-axis, value of x in y-axis, it still is okay, no problem for scatter plot. Even for finding r also is okay, no problem. But for finding slope and intercept, we have to know which is dependent and which is independent. Let's move to 4. In a simple linear regression equation, the symbol x is represent what? When I write y here, for example, y dash equal 1.57 plus 0.0407x. Here x is what? In this regression line, x is, yes, x is independent.
Whatever value we assign to it.
We have only two variables, this dependent variable and this independent. So y depend on x. Y is dependent. Also we call it outcome. Also we call it response variable. X X, we call it independent variable or explanatory variable. Both are same. So it is independent or explanatory variable. Both are right. For Y, we can say dependent variable or response variable or outcome variable. Okay, let's move to the 5. The range of correlation coefficient value R is -1, less than R, less than or equal 1. This value of R range between -1 to +1. Cannot be more than 1, cannot be less than -1. When all the point fell on the regression line, what is fell on the regression line, what is the value of correlation coefficients? If all values fell on regression line, so correlation coefficient R could be positive, could be negative, could be -1, could be 1 if regression line is negative, could be -1 if regression line cannot be 0, because all actually it is a perfect correlation, perfect relations. So let's move to which one? 7. In correlation coefficient R is equal to -0.75. This means what? Is it positive, negative, strong, weak, moderate relations?
Strong negative relationship between two variables.
Yes, negative, strong. Negative or strong negative relationship between the two variables. If plus 0.97, then it is
Strong positive relationship between the two variables.
yes, exactly. So let's move here to find these questions. It was exam questions. Suppose 5 individuals with the same initial systolic blood pressure are given blue. So this is a summation of already we don't give in exam. I think they will not give, especially this years, because exam 2 hours. So just maybe they will give you these summations. Ready? N equal summation x square, summation y square, summation x y. First question, compute correlation coefficient for the data. Just we use this actually given in exam. So we just, instead of n, we use 5. Instead of summation x, y, we use this summation x, y. Then summation x, 150, summation y, 965 over square root of 5 is 5. Summation x square, summation x square is this. Okay. Summation x all squared should be this. So in exam, make sure we use this same here, just square it. Also, we use this same, just you square it. Value is -0.886. Describe this relation, just we write it is negative. Why negative? Because it is negative. Why strong? Because it is close to 1. So it is negative, strong, linear relationship. Linear relationship by default. So question 2, find intercept and find slope. First, to find intercept, we need to find slope. So b equal n, same, this, same. So just in calculator, try to find this, because you already will get it here. Just put it here. Also here, this value is the same value. 5 multiplied by 5,500 minus 150 square. This value same. So to save time, just take this, put it here. So b is -12. should be negative. Why negative? Because already we get R negative. So if this positive, this negative, and you got this positive, then something wrong. This should be same. Negative also, this should be negative. Then to find A, just we use y bar minus b x bar. Is shortcut for getting intercept. Y bar already we have summation. Just we divide this over n. For x bar, just we divide 150 over 5 x bar multiply by minus half, which is b. So we get 150. Question 3, write the equation relation equation of the regression line of the data y hat equal b equal a intercept minus b slope x. Question 4, predict value of y if dose x is 64. Just instead of x we write 64. So this person if he use 64 milligram, his blood pressure would be around 122, and this is logic because the normal is 120. So we finish. Question exam will be same. If MCQ somehow will be similar, if essay question will be same also. So just do practice how to use this formula, how to find R, how to find B, how to find A, how to describe the relation, is it positive, negative. Also how to draw a scatter plot, X with Y, and from scatter plot, you indicate the direction, strength of the relation. Now we finish class. Any question?